Okay, welcome back to what should be the last video in this series about the sampling distribution of the sample mean. Alright, here's where we left off with the previous video. We found the probability that the mean of a sample that you take is less than 62.6. And the area that corresponded to the z-score that we had calculated, the z-score down here, was 0.3194. That area is interpreted as a probability. It can also be interpreted as 31.29%. Probability can be expressed either as a decimal or as a percentage. So from this point, our first step again is to calculate the z-score of the number in which we are interested. So we do that, then we refer to the z-table, and on the z-table we find that the area that corresponds to a z-score of 1.57 is 0.9418. That means that's the area to the left of that z-score, which would be here. However, that's not actually what we are interested in. What we are interested on is when x is greater than 68.7 or to the right of the z-score of 1.57. Therefore, we cannot just accept the area as given. We have to find the area that is equal to 1 minus 0.9418. And that area is 0.0582. So the probability that your sample of 36 individuals has a value greater than 68.7 is 0.0582 or 5.82%. By the way, if I ever rush through something like taking a z-score and finding the area from the z-table and you're not comfortable with that, go back and watch one of the other videos in which I discuss how to read a z-table. So now we have two values to work out. So we need to find the z-score of 59.8, and we also need to find the z-score of 65.9. We are looking at a z-score of negative 1.4, and that's the area to the left. And a z-score of 0.633, and there's the area to the left of that. But the area we are really interested in is the area between the two. The area between the two numbers, we will take the larger area, 0.7357, and subtract from it the smaller area. And we get an area of 0.6549. That is the area between the two z-scores. And that is the probability that your sample mean will be between 59.8 and 65.9. Also, you could express that as 65.49% probability that the mean of your sample will be between the two given numbers. Okay, so if you have a distribution from which you are taking a sample of size 20, it has a mean of 64 and a standard deviation of 17. There is one thing that must be true of that distribution before you can use the techniques we've been using, and that is the population must be normally distributed, or approximately normally distributed. Since the population from which we take our samples is normally distributed, we can describe the sampling distribution of the sample mean. And the first thing we can say it is approximately normally distributed. Okay, so there's the shape, bell-shaped, normally distributed. Okay, and the mean of the sampling distribution is 64, the same as the mean of the population. And then the standard error of the mean we have to calculate. So the standard error of the mean is the standard deviation, 17, divided by the square root of the number of individuals in the sample. So the standard error of the mean is 3.80. And with that, we can find all sorts of probabilities that the mean of a sample will be less than or greater than some number or between two numbers. And I will discuss that further with you during class time. I'll see you then.